Hello everyone. In this session, I would like to share with you the method of solving the different first order ordinary differential equation, that is separation of variables. First order ODE can be reduced in the form of gy dy dx equal to fx, or we can write in the form of gy dy equal to fx dx. So from the wording of separation of variables, it means you separate the variables. So we separate the variable x and y. Okay, if you look at here, this means that we separate the variable y to the left hand side and we keep the variable x to the right hand side. And both sides of equation can be integrated. And we call this is separable differential equation. Now let's look at the example. Solve the differential equation x power of 3 dy dx equal to 2y with the initial condition y when x equal to 1 over, and when x equal to 1 and then y equal to 1 over e. In order to solve these problems, you need to rearrange the equation to separate the x and y. So you keep the x at the right hand side and keep the y at the left hand side. So you bring the y here to the left and bring the x to the right. So now you have 1 over y dy equal to 2 over x power of 3 dx. So now you separate the variable x and variable y. Okay. Next, you integrate both sides. Okay, so you integrate 1 over y dy equal to integrate 2 x power of negative 3. So you bring up the x power of 3 to the numerator. So you get 2x power of negative 3. You read it right. Okay, and then integrate the 1 over y, you get ln y plus c1. Okay, and equal to 2. You integrate this part, you get 2x negative 3 plus 1 divided by negative 3 plus 1. Okay, and then plus with c2. So you simplify, you get 2 as 2x power negative 2 divided by negative 2 plus c2. Okay, you cancel out this one. You get negative 1 over x power of 2 plus c2. At the left hand side, you have ln y plus c1. So your ln y equal to negative 1 over x squared plus c2 minus c1. We'll bring the c1 to the right hand side. So c2 minus c1 actually is just a constant. Okay, so it just c would be enough. So you need to taking the exponent for both sides. So by taking the exponent both sides, the equation could be rewritten as exponent ln x. So you make an exponent here. So exponent ln y equal to exponent negative 1 over x squared and then exponent c. Okay, so this exponent c, this one, is just a constant. So you can replace with a c. Exponent and ln you can cancel out. Okay, exponent and ln can cancel out, so you left y equal to exponent c, you get a c, it's just a constant, so c, and then you have the e exponent power of -1 over x squared. So this is the y value. So in your question, you are given the initial condition. You still remember the initial condition? Y1 equal to 1 over exponent, epsilon. So you need to replace this initial condition. So the third step is when x is equal to 1, y equal to 1 over epsilon. We replace the value of y and replace the value of 1. So 1 over epsilon, you get 1 equal to c exponent -1. And then exponent. This exponent is from here, okay? You multiply the exponent to everything. So you get c equal to 1. And now you know that the value of c, you can substitute the value of c into the equation of y. So y equal to exponent 1 or -1 over x squared. Okay, do you understand? Now we go to another example. Find the general solution for the first order differential equation dy over dx equal to y squared minus 1 over 1 minus x. So first of all, in order to solve this question, so first of all, we need to rearrange the equation. We want to separate the variable x and y. So we keep the variable x to the right hand side and variable y to the right hand side. So this part we move to here, and dx we move to here. Okay, now we have 1 over y squared minus 1 dy equal to 1 over 1 minus x dx. Okay, and then next step is integrating both sides. So you integrate 1 over y squared minus 1 dy equal to integrate 1 over 1 minus x dx. So we will solve this part first. 1 over y squared minus 1 equal to a y plus 1 plus b y minus 1. So end up and y plus 1 multiply with y minus 1, you will get y squared minus 1. So using partial fraction expansion, we solve this equation using partial fraction expansion. So if y equal to 1, so that is 1 a y minus 1. If a, then should be this one. Okay, so you have the b 1 plus 1. So your b is equal to half. Then if you have y equal to -1, this means you have 1 equal to a minus 1 minus 1. You get a equal to -half. Then you substitute the a and b value into the equation just now, this one. So you copy down substitute the value of a is -half plus b is half. Okay, and then integrate 1 minus x dx. Okay, so integrate 1 over y plus 1, okay, you get ln. So this -half, you can take it out as a constant only. So you integrate 1 over y plus 1 dy, you get ln y plus 1. And then plus with the half, again you get ln y minus 1 for this part, plus with c1 equal to, okay, integrate 1 minus x dx. So this one you get, since it's a negative here, so don't forget you have the negative, ln 1 minus x plus c2. Okay, c2 is a constant. So you can simplify, okay, you can simplify it. Negative half ln y plus 1 and then y minus 1. So you have half ln, okay, this one is y minus 1. Okay, negative is dy. Okay, dy y plus 1. Equivalent to negative ln 1 minus x plus c2 minus c1. So you bring, and then you bring the half to the right hand side. So you get ln y minus 1 y plus 1 equal to -2 ln 1 minus x plus c. Okay, you understand now, class? The second method to solve the first order ordinary differential equation is using the integrating factor method, okay, in linear differential equation. So what is linear differential equation? Okay, linear differential equation must fulfill the form of this: dy over dx plus pxy equal to qx. So this one we call the linear differential equation. So this equation is linear. So what is the example, or what are the examples of the first order linear differential equation? Now let's look at here. Dy over dx plus xy plus cos x. Okay, if you compare this equation with this form, okay, you have dy over dx, here also the same, and then pxy, okay, here also got y, and then px, okay, this px, this is the px, so px is equal to x. And then we compare with the qx. So qx, we have the cos here, so cos we need to move to the right hand side. So qx is the negative cos x. Now let's look at another example. Y prime, also in first order, we dy over dx, plus with the sin x y. So sin xy, so this one, the px is a sin x, and then qx is the value of 2. The 2 is not negative because you need to bring to the right hand side if you compare to this linear differential equation form. Okay, so you want the qx is at the location here. So you bring the 2 to the position of right hand side. That is the qx is equal to 2. And then if you have a dy over dx is equal to x power of 4, this means that this one pxy. So if you have, do you have any y here? No y. So no y, we assume that the px is 0. Then qx is at the right hand side. So qx is x power of 4. And then in linear differential equation, we need to take note that the coefficient of dy over dx in the first order linear equation must always 1. Okay, must always 1 in order to solve it by using the method of integrating factor. To solve the linear equation, we must follow the following procedure. Okay, this is the procedure. There's a 4-step. The step 1 is you need to write in this form. Second is find the integrating factor. The I is equal to exponent integrate with px dx. And the third step is use the formula y multiplied with the I equal to integrate the qx multiply with the I, which is obtained from the step 2, that is the integrating factor dx. And then step 4 is consider the initial condition. Okay, since we know the step, now let's do the example. Find the general solution for the first order differential equation x dy dx dy over dx equal to 4y plus x power 5. Okay, if you look at this equation, that is the x dy over dx equal to 4y plus x power of 5. If you still remember, just now I told you the coefficient of dy over dx is always 1. This one. The coefficient of dy over dx always 1. But if you look at the question, x dy over dx, this coefficient is not 1. Okay, this equation is not 1. You have the value of x here. So to do this, to fulfill the format, we must divide the dy over dx with the x. So now you get dy over dx. So you divide with the x. Then you bring the 4y to the left hand side. So 4y you bring to the left hand side, you get negative 4y over x, because divided by x, and then equal to x power of 5 divided by x. So here is x power of 4. Okay, from here, can you locate what is the px and what is qx? Do you still remember the format? Px, y. So if you compare this one, your px is this part. And then qx is equal to x power of 4. So now you can proceed with the second step. Second step is the find the integrating factor I equal to exponent integrate px dx. Okay. Px is negative 4 over x. So integrate 1 over x, you get ln x. So you take out the constant of negative 4, and then integrate 1 over x, you get ln x. Okay. So this is equivalent to ln x negative 4, power of negative 4. So exponent and ln can cancel out, so you get the exponent x power negative 4. Okay, you find the answer of integrating factor. And then the third step is to use the formula y multiplied with I equivalent to integrate qxi. So your I is x power negative 4. Qx also x power 4. And then I is x power negative 4. So this one can cancel out, you get just 1. Integrate 1, you get x. Integrate 1 with respect to x, you get x plus c. And then you bring this one to the right hand side, so you get y equivalent to x plus c over x power of negative 4. So you solve this one or you simplify, you get x power 5 plus c x power 4. Okay class, do you understand?